Yes, thank you, Marco. So first of all, I would like to speak a little bit about myself because I have never made a weather briefing before. I'm not an operational forecaster as most of you are. I am working in the field of the satellite meteorology, which part of it is to provide data and products to the forecasters, and I'm also doing some research and development, and as well involved in training of the forecasters. So I work very closely with the forecasters, but myself is not a forecaster, so please forgive me if this weather briefing will be a little bit different than usual. So first of all, okay, I just need to change the slide. Yes, I would like to know where you come from and what you do, which of the group you are. I will just give you the right to annotate, so you can show where you come from, and also if you can mark what you are doing. That would be very nice. Oh, nice, I see. Many of you are coming from Central Europe and some in eastern part, some are from the west. And let's see. Seems like most of you are actually trainers. Oh, and some forecasters as well. Very nice. Oh, good. Yeah. Most of you are forecasters, as I can see. Yeah. So thank you. So we will proceed with the current weather. So I was thinking that if we just look at the satellite image, what can we say about the current weather? We can, of course, obviously see the clouds. So from this image, what I can tell you, but probably you know more than me, then we have a cyclone here in this part. We may have another one down here, and it seems like a very large area without many clouds, which would tell me that this is an anticyclone with a high pressure level area, and here maybe as well. And I can also see some cloud streets here, which would tell me that probably there are some cold air advection going on, because that over the sea here can cause some very nice cumulus cloud streets. And I would tell that maybe, but I wouldn't be very confident that here we have a front along here. But what happens if we put here the mean sea level pressure? That would confirm us that, that indeed we have a high pressure system over here and there, and some low pressure system up here and over Turkey as well. And yes, we could see some fronts going over there. So now I would have a question for you. If we are looking at an OMSZ RGB, which you all know, I hope, could you tell me, or could you draw on this image where we have the polar front? So can you try to draw? Yes, where we would have the polar front. Very good. Very good. Okay. Can you also put here the subtropical front? Yes. that would be it. Yeah. Yes. Thank you. Very good. It was an easy question for you, I guess. So now we can try to have the geopotential height on the same level, same image. So we can indeed see here that the front would be here and there. And we can also try to have the isotachs on the same image, and then it also confirms us that the jet is right there. This is the 300 hectopascal isotach. And here is the subtropical jet. So very good, very good. So what do you think is happening now? We can have a look at the GFS forecast, and then we can see that the low pressure system, the high pressure system, which was over here, is moving towards the east right now, and at the same time, this cold air is coming down to the central and eastern and central part of Europe. So most of us will face a little bit of colder times. Now we have a very nice spring days with warm temperature and sun is shining outside, right over Hungary right now. But in the next few days we will have a cool air coming in, and it also may happen that on Monday we may have some snow, but we will see. So that would have been the first part, which was probably a little bit shorter than usual. But now I would like to share with you some of the features or some new things about the next generation of satellites, especially the next generation of the geostationary satellite over Europe. So you may have already heard about MPG, the Meteosat third generation. This will be a twin mission, twin satellite. There will be an imager satellite, and there will be a sounder satellite. The imager satellite will come first, and then the sounder satellite will follow. The sounder satellite will have an infrared sounder on it. This is something similar what we have on the polar satellites, the infrared sounders like YASI, ERS, CRIS, and other satellites and other instruments, and there will be another so-called UVM, Sentinel-4 instrument, which will be used to retrieve atmospheric composition and used in atmospheric chemistry models, possibly. But for us and for you as well, the imager satellite is very exciting. It will have a new imager instrument, the FCI, and also it will have a lightning imager, which would provide lightning detection from space. But now I will only talk a little bit about the FCI. This is a very busy slide. So in the middle, you have all the 16 channels of the FCI, which will be the follower instrument of Severi, which most of you are looking at now. So actually, it will have 5 new channels. These are marked with these boxes here. And as you can see here, you can also see that what is the main reason for having those channels. So we will have one channel in the blue region, one in the green, so we will be able to create true color images. This is something like we can see with our own eyes. That is very, very nice to have and very easy to interpret. There will be one new channel about low-level water vapor, one which will help us to detect more thin cirrus clouds, and there is one more which is about which will help us to see the particle size of the cloud tops. I believe that a couple of months ago, Andreas has already talked about some of the new RGBs which we will be able to have when we have the FCI. But now we can use two or several other instruments as proxy data. One of them is the ABI. This is on the GOES satellite over America, and I will show you some examples using that data. So this one of these new RGBs, which we don't have it right now, is using the IR 3.9 in the red beam, the 2.2 in the green, and the 1.6 in the blue. So what do you think? What would be the reason why would we have such an RGB? If you can type it in the chat box, what you think this RGB will be for? What do you think? We already have a 3.9 channel in the Saviri. What can we use this 3.9 channel? Yeah, we have one answer, detecting fires. Yeah, we use the 3.9 to detect fires. Particle size and phase. Yes, because we have the 2.2 and the 1.6, which are for that. Yes. So let's see what we have in this image. So if you can try to guess what we have 6 categories here, and we have 6 numbers. If you could try to put the numbers to the categories, I know you don't know this image. You don't know this RGB. I'm just thinking if you can guess what these colors could mean, and then we can go from there, and I can explain you what is going on. So you could use in the annotation tools there is this T which allows you to type. So you could put the numbers in each category. Okay, that's also a good idea to just take a line. Yes. Yes. So many of you think that number 5 is cloud-free water. Yes. Oh, we have some differences here. Cloud-free land. Number 4 and number 2. Number 1. Snow-covered land. Number 1. Water cloud. Number 6. Yes. Someone saying number 3 is ice cloud. Yes. We have no number in the other category yet. Okay. I think we can move forward. So no one put anything in the other categories, so I guess there is nothing to put there. So we can just move to the next slide, where we actually can see what is really about this RGB. This is called the fire temperature RGB. So this is to detect fires and also to estimate how warm the fire is. So we use the 3.9 in the red, which has arrived contribution when we have a very hot land surface, which also means low fire temperature, but we will see it later. In the green, we have the 2.2. This is physically related to the particle size and also to the length type. And it has a large contribution if we have small ice and water particles. And we have the 1.6, which relates to the particle phase. So when this is large, it has a large contribution to the water cloud. So you can also have a quick guide which you can access through this link later on. So let's try to see the categories again. So I think you have all put number 5 for cloud-free, and we had a little bit of difference for cloud-free land. There was, I think, number 1, number 2, and number 4 there. So if you could do the exercise again, what would you change? So if you can try to put your numbers where you would change things here, that would be nice if you could do that. Yeah, I see one, number 2 in the other category. That's nice, yes. Yes. We didn't have anything in the number in the other category. Now we have this little thing here. I hope you can see that. So yes, number 2 in this image, it looks like a fire. Yes. Yes, you are right. Fire is the other category. Yes. And it has a little bit of reddish color. So that means the temperature is not very, very, very high. Yes. Yes, we have still number 1 in cloud-free land, and we have number 4 in cloud-free land. So let's try to clarify that. So now we will move on to the next slide, which you are all know. So I think all the other categories were clarified, but we have number 1 and I think number 4 in the cloud-free land. So if you see in this image, you can see that number 1 has something like a cyan color, which in this image could mean 2 things. If this can mean it's either snow or either some very some ice cloud. So I don't think we can clearly know what's going on here. So if you go to the dust RGB, then we can see some color which most of us are not very familiar with, because this color I have not seen it very often, but it's clearly not a usual cloud color. So probably we have cloud-free land, but this is a cloud-free land which has actually snow. So this is another new type of RGB, which some of you have already seen in Andreas' presentation. This is the so-called cloud type RGB, and in this image you can also see what the colors mean here in the bottom. So here, green means it's snow surface. So in the fire RGB, when we have black in the color, that means we have very little contribution of in all the channels, and that is either when we have water surface or when we have land surface covered with snow. So that is the snow-covered land there. So here are the results, but you all did very well, so thank you. So now we will focus on the fire, because this RGB is actually one of the main purposes to detect fires. So using the 3.9 channel. So here you can see this reddish color, but it can change depending on the intensity, the temperature of the fire. So now you will have an animation. I hope you can see the fires, but I would like you to draw a circle around the fires you can see. Yes. Yes, very nice. Yes. I can probably try to start the animation again. So here you can see that sometimes it's white when we have a very hot fire. Then it gets to be white, the color. Otherwise, it's reddish. And in this image we cannot see, but in this RGB we can also see the burn scars, which is nice. But what we cannot see is the smoke of the fire. So if we want to see the smoke of the fire, then we can try to look at the true color RGB. In this case, this is a almost true color RGB. And also in the FCI, we will have a slightly different channel than the 3.9. This will be the 3.8, which will give us a better detection of the fires. That's why it changes. So I hope you can see the smoke here, and also can see the smoke in the other places as well, a little bit. Not so well, but still. So actually, I think this is from me. I hope you enjoyed it, and if you have any questions, please let us know.